On a quiet morning at NASA's Jet Propulsion Laboratory, the world changed. No explosions, no countdowns, just a press release. But those words would ripple across science, media, and imagination for decades to come. A revolutionary rotorcraft mission to Titan, Saturn's largest moon. The mission wasn't just another probe. It wasn't another orbiting satellite. It was something else entirely. A drone, an explorer, a flying laboratory, bound for a world with methane lakes, icy dunes, and a thick orange atmosphere, a world so alien, and yet possibly so familiar. Cut to archival audio, NASA announcement, recreated voice. This mission will redefine how we explore alien worlds. Titan offers conditions we've never had the chance to study this way before, and Dragonfly is how we'll do it. For most people, Titan was just a name, a speck in a sea of stars, a moon orbiting a ringed giant. But for planetary scientists, it was the prize. A place that ticked all the boxes: thick atmosphere, complex chemistry, possible subsurface ocean organic molecules, and most importantly, prebiotic potential, the seeds of life. Or something like it. Titan had always whispered questions. Now NASA was ready to go there and demand answers. Let's rewind. Titan orbits Saturn, the second largest planet in our solar system. It's not just big, it's massive. In fact, Titan is bigger than the planet Mercury, but what sets Titan apart isn't its size, it's what's on it. Its thick, nitrogen-rich atmosphere is unlike any other moon. It's cold, colder than Antarctica's harshest nights. But despite that, Titan has rivers, lakes, storms, clouds, not of water, but of liquid methane and ethane. Imagine walking along a beach made of frozen hydrocarbons, under an orange sky, with icy winds whispering across a strange world. That's Titan. And beneath that frozen surface, possibly an ocean of liquid water. The building blocks of life may be locked inside. And NASA? They plan to fly a machine like a helicopter over its alien landscapes to land, sample, fly again, land again, over and over. Dragonfly wasn't just a mission. It was mobility. It was intelligence. It was freedom. Ahmed Elgendi. Chapter 3. Why Titan? Why now? NASA doesn't just launch missions because they can. They launch them when they must, when the timing, the technology, and the science all align. That's what happened with Titan. So, why now? Because we're running out of time to understand what life needs to survive, to evolve, to begin. And Titan is the best laboratory we've got. Cut to interview snippet, fictional planetary scientist. Titan is a preserved time capsule. It's like Earth, but 4 billion years ago. Before photosynthesis, before oxygen, before life as we know it. By studying Titan, we're not just looking for life, we're looking for the recipe. And the urgency? It comes from two directions. Scientific breakthroughs in prebiotic chemistry, technological leaps in drone navigation, AI, and autonomous systems. Dragonfly is powered by a nuclear generator. It can fly dozens of kilometers at a time. It carries a full suite of instruments: mass spectrometers, seismometers, weather sensors. Every landing zone is a chance to collect data. And every flight brings us closer
10,
to the
9,
truth.
8,
Chapter
7,
4. Building a machine
5,
for an
we have
alien
program ready
world.
to start. 2,
Designing a spacecraft
1,
is never
0.
simple.
Booster ignition
Designing
and
one that
liftoff
flies
of
in the
Shuttle Endeavour,
atmosphere of a
NASA's final
distant
space
moon,
station crew compartment,
that's
to
something
bring
else
the Bay window
entirely.
view to our celestial backyard.
NASA had to answer hard questions. How do you fly in 1.45 atmospheres of pressure? How do you land safely on unknown terrain? How do you keep the instruments warm at minus 179 degrees Celsius? And how do you control a drone from 1.4 billion kilometers away? The answer was Dragonfly, an 8-rotor, nuclear-powered aerial robot. Each rotor precisely engineered, each sensor carefully shielded. It doesn't rely on real-time human control. Instead, it thinks for itself. It maps, it analyzes, and it decides where to land next. Cut to fictional NASA engineer quote, "We had to build something that could survive Titan, but more than survive, it had to thrive. No wheels, no rovers, just wings, a dragonfly, dancing above alien dunes." Countdown to launch. When NASA sets a launch date, it isn't just a calendar entry, it's a promise. To scientists, to engineers, to the public, and in this case, to the future. Dragonfly was scheduled for launch aboard a heavy-lift rocket, a journey of more than 7 years across the solar system. But before it could even leave Earth, it had to prove it could survive Earth's toughest tests. Inside the testing chambers, vibrations like a rocket launch, heat like the inside of a volcano, cold like the shadowed craters of Pluto, vacuum like deep space. And the team watched, measured, tweaked again and again, because failure wasn't an option. This mission had no backup, no second chance, no way home. Once Dragonfly launched,